Hello students of class 10. In this video we will discuss exercise 8.2. First question saying that prove that the external bisector of any angle of a triangle divides the side opposite to the angle in the ratio of the other two sides. External bisector of any angle of a triangle, okay, divides the side opposite to the angle in the ratio of the other two sides. Okay, the external bisector of any angle of a triangle divides the side opposite to the angle in the ratio of the other two sides. Okay, that means in here you see hint given, the external bisector AX of angle A of triangle ABC meets BC extended at X. CD is drawn parallel to XA meeting AB at D. Then BX by XC is equals to BA by AD. Okay, but AD is equals to AC, BX by XC is equals to BA by AC. That is, you see, BX by XC is equals to BA by AC. BX by XC is equals to BA or AB by AC. That one I have to prove here. So you see, this is our triangle. Okay, your diagram in here, this is our triangle ABC. ABC, this is our triangle. Okay, ABC, this is our triangle. Finished? Okay, and next you see BC is extended to X. Okay, BC is extended to X. So this external bisector of angle A, AX, meets BC extended to X. CD is drawn parallel to XA, okay, meeting AB at D. CD is drawn parallel to AX, meeting AB at D. Finished? This is your D point. Okay, this is your D point. Now you see, given ABC is a triangle. Finished? ABC is a triangle. AX is the external bisector of angle A. Angle A is this one. In triangle ABC, angle A is this one, and external angle A will be this one, this whole angle. And AX is the external bisector of angle A. Finished? Okay. To prove that, what I have to prove here, I have to prove that BX by CX, okay, BX by CX is equals to AB by AC. BX by CX is equal to AB by AC. That one I have to prove here. So construction I will do. Through C, a line is drawn parallel to XA which intersect AB at D. Through C, a line is drawn parallel to AX or XA which intersect AB at D. Understand? That is, CA perpendicular to XA is drawn. Okay. Next, proof. Since AX is parallel to DX, AX is parallel to DC. Okay, DC. AX is parallel to DC. AX is parallel to DC. Finished? Okay, and BE you can consider it as the transversal. So therefore you see this angle will be is equals to this angle. I can say that EAX is equal to ADC. This angle will be is equals to this angle. Why? Corresponding angles. You see, these two corresponding angles. And that one I will take it as equation number 1. Next again you see this is parallel to this. Yes, if I consider next AC is the transversal, then what I will get? Then I will get that you see this angle will be is equals to this angle. Yes, alternate angles. Understand? This angle will be is equals to this angle. Alternate angles, and this one, that one I can consider it as equation number 2. Finished? And next you see this angle will be is equals to this angle. This angle, these two angles will be equal because AX is the external bisector of angle A. Yes or no? AX is the external bisector of angle A. So therefore next I will write that EAX is equal to XAC. So from first I am saying you see AX is parallel to DC, so therefore this angle is equals to this angle, corresponding angles, and this angle is equals to this angle, alternate angle. Yes, and next this angle is equal to this angle, and that will be equation number 3. So from 1, 2 and 3 what I am getting here, you see this angle is equal to this angle, this angle is equal to this angle, and this angle is equal to this angle. Okay, understand? See, this angle equal to this angle is equal to this angle, and this angle is equal to this angle. Okay, so from 1, 2 and 3 what I can say that this angle ADC, this angle is equal to ADC is equal to ACD. Okay, this angle equal to this angle equal to this angle, and since these two angles are equal, so these two angles will be also equal. From 1, 2 and 3 I got that this angle is equal to this angle. Finished? So in this triangle ADC, if these two angles are equal, then I can say that these two sides will be equal. Therefore AD is equal to AC, I can say. This theorem you have already learnt in lower classes. Understand? If two angles of a triangle are equal, then the side opposite to those equal angles are also equal. Yes or no? Sides opposite to equal angles of a triangle are equal. This angle is equal to this angle, so therefore this side will be equal to this side. Finish? This one we got. Again you see, again CD is parallel to AX. Yes, CD is parallel to AX. So therefore what I can say, this is parallel to this. Okay, so therefore I can say that AB by AD is equal to BX by XC. This is basic proportionality theorem. This triangle you see BAX, this whole triangle you see, in this triangle this is parallel to this, so therefore what I can say, this by this is equal to this by this. Yes or no? This by this is equal to this by this. This is our basic proportionality theorem. Yes. Now again you see, this by this. Yes or no? This by this is equal to this by this. Yes. So now AD is equal to AC I got. So instead of writing AB by AD, I can write AB by AC. Yes, AB by AC is equals to BX by XC, and this is our proved. One more time I am explaining, you see. One more time I am explaining. I have to prove here that the external bisector of any angle of a triangle. Now in here I have taken external bisector of angle A divides the side opposite to the angle. Yes, divides the side opposite to the angle in the ratio of the other two sides. Okay, now angle opposite, side opposite to angle A is BC. BC I have extended it to X. Okay, so in here saying that AX, okay, AX divides BX in the ratio of the other two sides. In here you see one thing, AX, okay, AX divides BC, okay, not BX. I said AX divides BX in the ratio of the other two sides. Actually it is AX divides BC in the ratio of the other two sides. Understand? So that is, I have to prove that in here, that is I have to prove that AB by AC is equal to BX by CX. Okay, so that one in here I will have to prove. Understand? Okay, so therefore in here I have to prove that this is BX by CX is equals to AB by AC. Okay, or AB by AC is equal to BX by CX, whatever you do. Finished? So now ABC is a triangle, yes, and AX is the external bisector of angle A. Okay, to prove that BX by CX is equals to AB by AC. Okay, now in here I will CD parallel to AX I will draw in the construction. Okay, CD parallel to AX, this one it will go to the construction, and then you see in proof this one CD is parallel to AX, so therefore this angle will be is equals to this angle. Corresponding angles, equation 1. Next again this angle will be is equal to this angle, alternate angle, equation 2. And since AX is the external bisector of angle A, so therefore this angle will be is equals to this angle, equation 3. From 1, 2 and 3 I can say that this angle is equal to this angle. So therefore I can say that AD is equal to AC. Okay, AD is equal to AC. Now again, since this is parallel to this, now by basic proportionality theorem I can say that, okay, by basic proportionality theorem I can say that this by this, okay, AB by AD is equal to this by this. Understand? This by this is equal to this by this. Finished? AB by AD is equal to BX by CX. Done. Next line I will write, since in here I have got that AD is equal to AC, so next line I will write that BA by AC, yes, BA or AB, whatever you write, BA by AC will be is equals to BX by CX, and that is our proof. Understand? That much only. In here again nothing there. Question number 4. Show that the external bisectors of two angles and internal bisector of the third angle of a triangle are concurrent. Okay, so that the external bisector of two angles and internal bisector of the third angle of a triangle are concurrent. So this will be your diagram. Okay, this will be your diagram. This is triangle ABC. Okay, now you see this one OB and OC. Okay, OB and OC are external. This is, it was AO is the internal bisector of angle A. It was given in the note. Do not write this. Okay, given only OB and OC are the external bisector of angle B and C which intersect at O. Understand? OB and OC are the external bisector of angle B and C which intersect at O. Understand? This is internal angle B, yes or no, and this will be the external angle. This is triangle ABC. This angle will be the external angle of angle B, that is external angle B, and BO is the bisector of this angle. Understand? So therefore BO and CO are the external bisector of angle B and C which intersect at O. Finished? To prove that OB, OA and OC are concurrent. That means these three lines, they meet at a point. Okay, or yes, OB, OA and OC. Okay, this is C. OC are concurrent. That means these three lines, they meet at a point. Okay, now construction. OD perpendicular to AB produced. Okay, OD perpendicular to AB produced, and OE perpendicular to AC produced. Understand? This is OD. Okay, OD, this is D. OD perpendicular to AB produced and OE perpendicular to AC produced. Understand? And OF perpendicular to BC is drawn. Three perpendiculars. Okay, OD, OE, OF. Three perpendiculars are drawn. Finished? Okay, in here it is saying that so that the external bisectors of two angles and internal bisectors of the third angle of a triangle are concurrent. Okay, so these two are the external bisector. These two are the external bisector. Okay, and this one I have to prove that this is the internal bisector. Okay, if I can prove that this is the internal bisector, then it is proved that OB, OC and OA are concurrent. Understand? So in here OB and OC are the external bisector. OB and OC are the external bisector. Diagram will be in this way. Okay, this is triangle ABC. ABC. Finished? And then these two are external bisector. This is produced, we produce it. Okay, these two are external bisector of angle B and C that meet each other at O. Understand? And then this one AO, I will join it. Understand? AO, I will join it, and I will prove that AO is the internal bisector. Understand? AO is the internal bisector. Okay, OB and OC are external bisector, and AO, I will join it. Understand? Now you see it is looking only that these three lines are concurrent. So therefore just I will prove that AO is internal bisector. Yes, so therefore I can say that this and this are concurrent. So from here I will draw a perpendicular, from here I will draw a perpendicular, and OF I will draw a perpendicular on BC. Okay. So given OB, OC are external bisector of angle B and angle C which intersect at O, and in given only I will write this is join AO. Okay, in given only join AO. Finished? To prove that OB, OA, OC are concurrent. That means OB, OC, OA, they meet at a point. Okay. OB and OC are external bisector, I know. I have to just prove that AO is the internal bisector. Understand? AO is the internal bisector of A. Then it will be proved. Okay. So construction, OD perpendicular to AB produced and OE perpendicular to AC produced. Finished? And OF perpendicular to BC is drawn. Now proof. You see, since OB is the bisector of angle DBC, okay, since OB is the bisector of angle DBC, this one you see, OB OB is the bisector. It is the external bisector. Yes or no? OB is the bisector of angle DBC. Yes, OB is the bisector of angle DBC. Okay. Internal angle B is this one and external angle B is this whole angle. And OB is the external bisector of angle B. Yes. External bisector of angle B. External angle B is DBC, yes or no? And OB is the external bisector. That means this angle OB bisect doing. Okay. So therefore OB is the bisector of DBC. Finished. Okay. OB is the bisector of DBC. So therefore I can say that OD is equal to OF. Okay, OD is equal to OF. Since this one you see, OB is the bisector of angle ABC. Understand? That means in here what saying, if you take an angle, okay, if you take an angle here and you bisect this angle, from any point on this angle bisector, any point you take and you join doing this way. Join, do and go. In this way you join, do and go. So what you will get? You will see that this side is equal to 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 this side. Understand? Okay. That is, join means perpendicular distance you will have to draw. Okay. Perpendicular distance you will have to draw. They are all 90 degree, 90 degree. Perpendicular distance you will have to draw. Understand? So you will see that this side equal to this side equal to this side equal to this side equal to this side you will get. So since OB is the bisector of this angle, yes, so therefore OD will be is equal to OF. Match it with this one. In here OB is this line, OB is this line here, OB is this line, and this is the bisector of this angle. The arms of this angle are this one and this one, and this line is the bisector. So from this angle bisector, any perpendicular distance you draw on the arms of the angle, these two distances will be equal. So in here therefore I can say that OD is equals to OF. Understand? OD is equals to OF, equation 1. This one you will have to write, very important. Locus of a point equidistant from two arms of an angle is the angle bisector. Okay, locus of a point equidistant from two arms. Locus of a, what is the point? Okay, that it will be equidistant from two arms of the angle. Okay, understand? So those points, it will be the angle bisector. Understand? So therefore this one you will write, locus of a point equidistant from two arms of an angle is the angle bisector. Finished. Next you see OC. OC is the bisector of BCE. Yes, again OC is the bisector of this angle equal to this angle. OC is the bisector of BCE. Okay, so here what I will say? Here I will say that OE is equal to OF. Yes, OE is equal to OF. Again same. Yes, this is the bisector. This is the bisector from a perpendicular distance you draw to the two arms of the angle. Yes, these two distances will be equal. Okay, understand? So OE is equal to OF. Locus of a point equidistant from two arms of an angle is the angle bisector. Finished? From 1 and 2, one is OD is equal to OF and the second is OE is equal to OF. OE is equal to OF. So from 1 and 2 what you are getting? Equation 1 is OD is equal to OF and equation 2 is OE equal to OF. So from 1 and 2 what you got? OD is equal to OE. OD is equal to OE. Therefore OA is the bisector of angle A. OE is equal to OD, I showed, no? Yes or no? So therefore this one I can say that it is the bisector, because from this bisector the perpendicular distance I have drawn, okay, perpendicular distance, you see I have taken a point. This is the point, okay, this is the locus of the point. Understand? This point I have taken. From this point, if I draw two perpendicular distance on this arm, understand, if I draw two perpendicular distance on the arm of this angle, then these two perpendicular distances are equal. That one I showed, OD equal to OE. So therefore I can say that AO is the bisector of angle A. So next, these are concurrent. This is OC, okay, are concurrent. This is our proof. Okay, remember this one. Locus of a point equidistant from two arms of an angle is the angle bisector. In here, locus of the point is O here. From this point, okay, BO is the angle bisector. From this point, you take on this angle bisector, any point you take, I have taken point O here. From this point, if I draw two perpendicular to the two arms of the angle that this BO is bisecting, these two perpendicular distances will be equal.